Good morning, students. Today we will learn chapter 2, acid, bases and salts. How do you differentiate acid and bases? Acids are sour in taste and bases are bitter in taste. First of all, let us learn what are indicators. Indicators are certain substances that will tell us whether a compound is acidic or basic. How? On reacting with acid or base, this indicator will show some color change. Normally there are two types of indicator, natural indicator and synthetic indicator. Natural means from nature itself you will get, synthetic means that man-made. Natural includes litmus paper, which you have already heard. Turmeric is also a indicator. That means it can change color in presence of acid or base. Now synthetic indicators, two examples are phenolphthalein and methyl orange. The main property of these indicators are they will change their color in the presence of acid or base. Let us see what are the changes that you will see. Here let us see what happens to those indicators in the presence of acid or base. Turmeric, which is yellow in color, as you already know, but when it come in contact with a base, they change their color to red in the presence of acid and red in the presence of base. Now acid, if acid comes in contact with the red litmus, there will be no color change. The litmus paper will be red in color itself. But if base come in contact with the red litmus, it will change into blue color. Now, if acid comes in contact with blue litmus, the paper will change into red in color. And if a base come in contact with a blue litmus, there is no change. If an acid come in contact with phenolphthalein, phenolphthalein becomes colorless. Phenolphthalein is normally pink in color. It becomes colorless in the presence of acid. If a base come in contact with phenolphthalein, it will be pink in color. Now if acid comes in contact with methyl orange, it will turn into pink in color. And if a base come in contact with methyl orange, it will change into yellow in color. Now there is another type of indicator known as olfactory indicator. Olfactory indicator changes smell to tell if compound is acid or basic. Examples are vanilla, clove, onion and garlic. Now let us learn certain acids and bases that you will have to learn throughout the chapter. Name of some acids are H2SO4, sulfuric acid, HNO3, nitric acid, which is found in ant, when ants bite, right? HCl, hydrochloric acid, which is present inside your stomach. H2CO3, carbonic acid. CH3COOH, acetic acid or vinegar. Now name of certain bases are NaOH, sodium hydroxide, MgOH twice, magnesium hydroxide, AlOH thrice, aluminium hydroxide, CaOH twice, calcium hydroxide, KOH, potassium hydroxide. Now let us learn certain general reactions. Acid always, when reacting with metal, gives a salt and hydrogen gas is emitted. This statement you have to by heart. Whenever an acid reacts with a metal, it gives a corresponding salt plus hydrogen gas is released. Hydrogen gas is released. This is the main point of this reaction. The question can come like this. Hydrochloric acid reacts with iron filling, so form an equation. So you have already learned this above equation. Acid plus metal gives us salt and hydrogen gas. So hydrochloric acid, you know the formula of hydrochloric acid is HCl. With you will put a plus sign. Iron filling. Iron, what is the symbol of iron? Fe. Giving, you have to form the equation. What will both of this together form? It will give a salt and hydrogen. So before writing this salt, you will write H2, hydrogen. And what is left? Fe is left and Cl is left. So you will write FeCl. And when you balance the equation, you will get 2HCl plus Fe gives FeCl2 plus hydrogen. Let us see another example. Okay, sulfuric acid reacts with aluminium powder. And your question is form equation. So sulfuric acid, you know the formula is sulfuric acid, you know the formula is H2SO4. Reacts with, you will put a plus sign, aluminium powder. Aluminium, the symbol is Al. And the equation, you know that since acid and metal react, hydrogen gas is released. So you will first write H2. Then you will go what all are left. Al was left, SO4 was left. Al, SO4. When you balance it, you will get Al2, SO4 thrice. Now, when scientists was performing these reaction with acid and metal, they found that hydrogen gas was liberated. But hydrogen being a gas, how can the scientists find that hydrogen gas was liberated? The main specialty of hydrogen gas is it burns with a pop sound, put put put. Okay, and that is how you can find that there was a hydrogen gas released. So in certain reactions, it will not be said that hydrogen gas was released. They will say on this reacting, this put put sound was, crackling sound was there. So what is the equation? So if that sound is there, that means it indicates the presence of hydrogen gas. So now take out your pencil and a paper and try to solve this equation. H2SO4 plus Zn, that is sulfuric acid reacting with zinc. What does it give? Now next, HCl plus Mg, magnesium. When hydrochloric acid and magnesium reacts, what will be the equation? Just take down in your notebook and try to answer it. You know that H2SO4 and HCl is a acid. Zinc and magnesium are metals. So acid and a metal on reaction gives a salt and hydrogen gas. Come on, I am waiting. Write down the answer. The answer is sulfuric acid and zinc reacts together to form zinc sulfate and hydrogen. HCl and magnesium reacts to give magnesium chloride and hydrogen. Now next reaction is acid reacts with metal carbonate or metal hydrogen carbonate. So on this reaction, salt is produced, carbon dioxide is produced and water is produced. So this particular statement you have to learn by heart. When an acid and a metal carbonate or metal hydrogen carbonate reacts, what is obtained? A salt, carbon dioxide and water. 3 products are formed. See, just imagine an acid. The main part of acid will be a positive ion part and a negative ion part. Let us consider it to be made up of A plus and B minus ions. Similarly, for metal carbonate also, there will be positive ions and negative ions. Let us consider it to be C plus and D minus. That means when the salt is formed, salt takes the negative part of the acid and the positive part of the metal carbonate. Let us see with the example. Na2CO3 plus HCl, sodium carbonate plus hydrochloric acid gives NaCl, that is sodium chloride, plus carbon dioxide plus water. Carbon dioxide plus water is fixed, right? NaCl is formed. Now the same way, if the acid reacts with Na2HCO3, that is metal hydrogen carbonate, sodium hydrogen carbonate, reacts with HCl, similar reaction. It gives sodium chloride plus carbon dioxide and water. See, let us see a question. A metal compound reacts with an acid to produce effervescence. The gas evolved extinguishes a burning candle. White balance equation for the reaction. If one compound form is calcium chloride. So in the statement, it says that the gas evolved extinguishes a burning candle. That means the gas produces carbon dioxide. Okay, the carbon dioxide is produced, and it is also said one compound formed is calcium chloride. So we have to form the equation. Now calcium chloride CaCl2 is the salt which was formed. So it can be formed from two compounds, calcium carbonate and HCl. So the reaction will be CaCO3 calcium carbonate plus hydrochloric acid giving calcium chloride plus carbon dioxide. Carbon dioxide helps in putting out candle plus water. Next reaction is acid and a base. Acid and a base, when it reacts together, it is a neutralizing reaction. Its reaction gives a salt and water. That means acid and a base, when it reacts together, a salt is formed and water is released. For example, NaOH, sodium hydroxide, which is a base, reacts with HCl, which is an acid, giving NaCl, which is a salt, plus water. So here acid plus base giving salt and water. The same way acid plus metallic oxide also gives salt and water. So this means that metallic oxides are bases in their properties. The same way, non-metallic oxide plus base also gives salt and water. That means non-metallic oxides are basically acids. Next is pH scale. You know that acids and bases, they are either strong acid or weak acid, and there are even strong bases and weak bases. Now how will you know whether an acid is strong or weak, a base is strong or weak? It is measured using a scale known as pH scale. The values of pH varies from 0 to 14, and the midpoint of this pH scale is 7. If the value of pH lies between 0 and 7, it is an acid, and if the value lies between 7 and 14, it is a base. And if the value is 7, then it is called neutral. Now acid itself, if the pH value is near to 7, the acidic nature is less. That means it is less acidic. And if it is nearby 0, that means it is more acidic. For example, if you consider a pH value of an acid to be 6.9, that means it is less acidic. And if the pH value of an acid is 1, that means it is more acidic. The same way, in the basic scale, if the value of the base pH is nearby 7, that means it is base, less basic. And if the value of pH is nearby to 14, that means it is more basic. Now here I have given two liquids having pH 4 and pH 1. Now tell me what are A and B? Acid or base or both? pH values 1 and 4. It lies between 1 and 7. That means both are acid. Now tell me among them which is a strong acid, A or B? Yes, B is the strongest acid and A is weak acid. Now here I have two other solution having pH 13 and pH 10. What are these? Are they acid or base? Yes, very good. They are base because the value is more than 7. And which is the strongest base, C or D? Yes, D is the strongest base and C is the weakest base. Now strong acids are dangerous. Okay, strong acids, it can even burn your skin. So it is necessary to dilute acid. Okay, strong acid means the acid is highly concentrated. Okay, and in order to decrease its strength, you need to dilute it. How will you dilute it? By adding the acid into water, you can dilute it. So when you add acid into water, should not do the other way. You should not put water into acid. It will burn. Should put acid into water to dilute it. So when acid is added to water, it produces heat because this reaction is exothermic reaction. Exothermic means heat is generated. Now acid, when reacting with water, H plus ions are given, and these H plus ions are responsible for the acidic nature of the acid. Whereas when base react with water, OH negative ions are released, and these OH negative ions are responsible for the basic nature of a base. Last part of this chapter is salt. Salt normally contains a positive part and a negative part. And the salt that is in your house, in your kitchen, that is an example for a salt. It is NaCl, sodium chloride. The common salt that you find in your kitchen is sodium chloride. How is sodium chloride formed? Sodium hydroxide plus hydrochloric acid gives sodium chloride and water. Which reaction is this? Base plus acid giving salt plus water. NaOH is a base, HCl is an acid, NaCl is a salt. Now this is a reaction in which sodium chloride aqueous solution is taken, NaCl plus water, and it is called brine, and electricity is passed through it. So when electricity is passed, anode and a cathode is there. Anode is positive in charge and cathode is negative in charge. So on the reaction you can see sodium hydroxide and calcium and hydrogen are released. Calcium being negative ions attract towards the anode, and hydrogen being positive attracts to the cathode. And this sodium hydroxide, you can see it is found nearby the cathode, nearby the hydrogen. This process is called chlor-alkali process. Here you can see what are the uses of this particular reaction in which you get hydrogen, chlorine and sodium hydroxide. Hydrogen is used in fuels, margarines, ammonium fertilizers. Chlorine can be used for water treatment in swimming pools, PVC disinfectants, pesticides. Sodium hydroxide can be used in degreasing metals, soaps and detergent, paper making and artificial fibers. If this hydrogen and chlorine reacts together, you will get hydrochloric acid, which can be used for cleaning steel. Ammonium chloride used as medicine, cosmetics. Now if NaOH and chlorine reacts together, you get bleach, which can be used for household bleaching and bleaching fabrics. Now next is bleaching powder. The formula is like this: CaOCl2. And how is it formed? By the reaction of calcium hydroxide, CaOH twice, plus chlorine, Cl2. And its uses are as mentioned before. It is used in mostly washing clothes in the industries and also disinfecting drinking water. Next is baking soda, formula NaHCO3. And how is it formed? By the reaction of sodium chloride, water, carbon dioxide and ammonia, baking soda is formed. What is the use? For making baking powder. Now you know that sodium carbonate, NaHCO3, reacts with H plus to give carbon dioxide, water and sodium salt. Now next is washing soda. It is Na2 CO3, 10H2O. So how can it be formed? By heating sodium carbonate, you can get washing soda. Now what are the uses? It is used in glass, paper and soap industries, in manufacturing sodium compounds such as borax, and it is used as a cleaning agent also. It also removes permanent hardness of water. Now the last salt is gypsum, which the formula is CaSO4 2H2O. On hot heating gypsum in 373 Kelvin, you get CaSO4 half H2O, which is plaster of Paris. And plaster of Paris is used as a treatment for fractured bones, right? So with that comes the end of this chapter. Have a good day.